Good morning, class. So today I'm going to show you how to do a time simulation for a full wave rectifier ACDC converter. One thing, bonus complete, ACDC converter. Forgot to add that. Okay, so basically what we have here is we have a full wave rectifier but with a cap and a resistor on the output load here. So basically what's happening is this is low passing it. In the example that we're doing, this doesn't do a particularly good job of low passing it, so we have fairly high ripple, which you'll see here in a little bit. What you should have seen when you did the full wave rectifier circuit is when you're passing a sinusoidal wave, you should see humps. Basically, in one period, you'll see two humps. And on a half-wave rectifier, when you pass the sinusoidal wave through, you only see the positive hump get passed through. So the reason why is, remember, the ideal diode turns on when you have a 0.7 or 0.6 volt, basically from here to here, positive drop across it. And so if this is at 0.7, this will be at 0 and it's barely turning on. If this was at 10 volts, this would be at 9.3. So as you're passing a positive sine wave, it'll be basically replicated here on this VF1 output pin. And as you go negative, this guy is reverse biased, turned off, goes into depletion region. You'll learn later what depletion region is in a different class. I think it's 140A. Now, when you look at the full wave rectifier, if I have a positive 10 volt rise from this terminal to this terminal, D1 and D4 will be on, but what you'll notice is now I have two diodes, so I actually have a 1.4 volt drop. So instead of previously it was what was it, 9.3, now it would be 8.6 volts. Basically you'd see 8.6 volts across here, because you have 10 volts across here, but you'd have a drop from here to here of 0.7, then you'd have a drop from here to here of 0.7. So this guy would be 8.4. Now if I had a rise, instead of a rise going from here to here in the opposite direction, if I had a rise from here to here, D3 and D2 would be on, while D1 and D4 would be off when we have current flow going through this way. So anyways, what we're going to be building is this final guide for the bonus. Now for the bonus, you actually have to build it. So we're not going to use small signal diodes. That's what was presented in the last video. That was the one in 4148. What we're going to do is we're going to use the switching diodes, the one in 4001 diodes. So we're going to place four of these guys. For you Windows users, you can just copy and paste. Mac users, you have to search over and over again. Like ideally what you would do is you would select both and then go Control C, Control V, but then what happens with Mac is you get this weird hyperlink and it's not the actual device, which is really annoying. So anyways, it's this program was made natively for Windows. So anyways, we will add all the four guys that we need as the Windows users are patiently waiting for the Mac users to finish. Go ahead and wire all of them as you see in the diagram to the right. So usually the way I like to think about it is the the diodes kind of point in direction of this would be my positive terminal for my output, and this would be my negative terminal for my output. I'm going to draw, excuse me, a little under the weather today. I'm going to draw this a little bit differently. Instead of having supply on the outside right here, I'm going to put the supply in the middle. So the next thing I'm going to do is I'm going to grab a voltage generator and I'm going to smack it right in the middle here, and I'm going to wire it up like so, and then let's double click on it. So let's call this V sine. Okay, and then the DC level we're going to keep at 0. We're going to change it from a unit step to a sinusoid. And we're going to change the, actually, well, let's leave the amplitude at 1 volt for now, just so you can see what happens. Let's do 60 hertz. Okay, so basically it's going to have a 1 volt amplitude, and then, actually, you know what? Let's change the amplitude to 0.5 per se. Okay, 0.5, okay. Press OK. Yeah, okay. And then now what we need to do is we need to add a resistor. Now the nice thing is it usually defaults on 1K for the resistance value, which it did. And we're going to wire this here. And then we're going to wire to the negative terminal over here, like so. I'm going to add a ground here. And now I'm going to add a 10 microfarad capacitor. Okay, right now it's 1 microfarad, so we're gonna make it 10 times bigger. Double click on it, type in 10 micro, press OK. Now what we're gonna do is we're gonna add a voltage meter here, wire it up, and we're gonna of course hook it to ground so it's not floating. Double click, and let's call this V out. Okay, and I put an underscore. So this is our, where aren't you moving? There you go. You moved too far. There we go. Okay. So this is our full wave rectifier. Save. Okay, so it's always good to save your work. So now what we do is we go to analysis, then we go to transient analysis, and so the period approximately for is like 16.666 blah 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 milliseconds. So let's do, I don't know, let's do like 45 milliseconds. That should give us around a little less than 3 periods. So anyways, now it's calculating. And so what you can see is if we go, if we separate curves, so V out is really tiny, and when you recombine, if you go view, collect curves, as you can see, it looks like it's flat. Reason that is we didn't give it enough voltage to really turn on the diodes, 4 bias diodes. Now if we increase this to 1 volt like it was originally, this should be enough to forward bias the diodes. So now what we're going to do is we're going to go analysis, transient, and run again. Okay, so we're showing a little bit. Now if we go view separate curves, which you'll notice is it's starting to rise. Okay. Now what we can do is let's do another one. Let's increase this, and let's change this to like 5 volts, so we're getting 10 volts peak to peak. Let's go ahead and save. Now this time when we do the transient analysis, well, we're allowing it to, we can use initial conditions, 0 initial conditions, and I'm doing calculate operating point, so it should get it closer to the actual final operating point. But let's run it for 1 second, and let's see what, actually no, let's do 45 really quick, milli, so you can actually see. So as you can see right here, it's turning on, and it's actually reaching a steady state pretty quickly. So what's happening is the capacitor or the resistor value is too small. Sorry, that it's too small, so it's basically draining the capacitor pretty quickly. If I was to copy this circuit and change the resistor value, which let's do that really quickly. Unfortunately, I cannot copy and paste this very quickly, but if I was to do another circuit, what you'll see is that the slope would be different. If I was to increase the resistance, the slope here would be different. If I increase the capacitance, it would also be different. So let's go ahead and do that really quick. So what I'm going to do is I'm going to, let's see, I'm going to make a jumper, rotate left. So what I'm going to do, the reason I'm making a jumper is, I think I want a jumper. Hold on a sec. Actually, you know what? I think if I just label the nodes, I can hook it that way. Yeah, so it's been a while. So we'll call this V sign positive. Okay. For AC, it doesn't matter. Oops, why didn't that show up? Oh, show ID. Okay, and then click on this, go V sign negative. Okay. So now what I've done is I've labeled these two wires. So what I'm going to do is I'm going to replicate the circuit right below it. And so just replicate it as I replicate it. Cannot find blank because I didn't tell where to search. Okay. Okay, let me add a couple more of these guys. Like I said, it would be nice if I could just copy and paste, but don't have that option. Okay, almost done. Insert. Okay, so what we'll do is we'll wire this up like the one at the top. And now what we're going to do is, of course, line these up. Now remember from the in the last video, you have to make sure that you have a dot to actually show that they're connected. So if I had put the sinusoidal source out here, I would have to overlap the wire. If basically you can overlap wires, but they won't be connected. So what I mean is if I have a wire that looks like this, if I have a wire that looks like this and this point are not connected. This looks like a graphical. It might not be connected there also, so you have to be careful about that. This program has some little bugs in it. Anyway, so let's put a capacitor down. It should be 10 microfarads as well. And let's go ahead and put down a, oh, I forgot, you can repeat last component. Oh, that would have saved me some time. Okay, that's okay. So let's make the resistor instead 10K. Yeah, let's make it 10K. Okay. Actually, yeah, we'll try 10K. Okay. And then we'll wire this guy over to here. And we'll wire it as before. We'll wire it all the way. We'll wire it there. Got to add our capacitor. Got to add a ground. Got to add a voltage meter. We're going to call this one V out 2. Okay, yeah, I know, very creative name. And there we go. Okay, so now the only thing is this is not connected to anything, so double click on it, and then what we'll do is V sign positive, and then double click on this right here. Oops, oh, it's behind here. V sign negative, Okay, so now those are connected, so save. So now what we'll do is we will run this again. So let's go Analysis, Transient, and go ahead and run it. So now what you'll notice is if we split the lathes, just to show you, if we separate outputs, this is our output 2, this is our output, and this is our original input. So if you notice how the new output with the higher resistance has smaller ripple, and the old output has fairly large resistance. So if we collect the curves again just to show that, you'll see that right here. So anyways, this is how you do AC simulation, or not AC, sorry, time simulation. AC is different, and I'm not sure if I'm going to introduce you guys to that. Thank you. Have a good day. Bye.